Hello, friends. Welcome to yet another interesting episode on our online tutorial on Prep Station. Today we'll be talking about pressure in fluids. Pressure in fluids. So what is pressure? Pressure is defined as the force acting perpendicularly per unit area, and it is measured in Newton per meter. It could also be measured in pascals or it could be measured in bars. So pressure is force per unit area. Now, if we want to go further, force can also be taken to be weight because it's mass multiplied by gravity. So we can also liken it to be mass multiplied by gravity all over area, which is pressure, if we want to refer to weight. Now, let's take a question on pressure and see. A rectangular block contains water of depth 2 meters. If the base of the tank is 4 meters by 3 meters, calculate the force on the base of the tank. So if you look at this question, they are giving us the density of water also here. So if you look at this question, they are looking for the force that is operating at the base of the tank. Density of water is 1,000 kilogram per meters cube, while gravity is 10 meters per second. The height of the tank is given as, or depth as the case may be, is given as 2 meters. So first of all, let's calculate pressure with respect to depth, which is usually density multiplied by height multiplied by G. So that's pressure. So pressure is density multiplied by the height multiplied by gravity. So 1,000 multiplied by 10 multiplied by 2. So if you multiply all this together, you're going to have your value there, which is going to be like 20,000, which is 20,000 Newton per meter. So now the pressure there is 20,000 Newton per meter. Now, what is the force that is acting as a result of that pressure? So pressure is equal to force over area. So if you want to get force, we multiply pressure by the area. And we already seen from the question that the base area is 4 by 3. So if you multiply 20,000 by 4 by 3, we're going to have 24. So our answer there is 2.4 times 10 raised to the power 5. So if we look at our options there, we have A 2.4 times 10 raised to the power 5 Newton, 2.4 times 10 raised to the power 4, 2.0 times 10 raised to the power 1.7. So the correct option there is A, which is 2.4 times 10 raised to the power 5 Newton. Now, let's go into pressure in fluids. Pressure in fluids. Now, pressure in fluid depends on the density of the fluid and the depth or the height in question of the vessel. So density is given as mass over volume. Density is always given as mass over volume. So if we know density is mass over volume, so if we substitute for mass, we are going to have density multiplied by volume. If we substitute for mass, we are going to have density multiplied by volume. And we know that volume is equal to area multiplied by height. And from our previously, we know that pressure is equal to force over area. Force over area. So if we substitute all these things together, so for force, we're going to have density multiplied by area, multiplied by height, multiplied by gravity, all divided by area. So that is how we got the formula. Density multiplied by height multiplied by gravity. So now, let's take a question here to apply the formula that we just derived. A 5 meter by 3 meter by 4 meter by 3 meter vessel of negligible weight is filled with a liquid of density 2,500 kilograms. If the vessel is placed on a flat surface, what is the maximum pressure it will exert? So we notice that pressure from what we just derived is density multiplied by height multiplied by gravity. So if we go back to the question, we pick the parameters one after the other. A density of the fluid was given as 2,500 kilogram per meter cube, while the height was given as 5 meters, and the acceleration due to gravity is given as 10. So if you multiply these three parameters together, 2,500 multiplied by 10, multiplied by 5, you are going to arrive at 1.25 times 10 raised to the power 5 Newton per meter. So if you check the options very well, 2.05 times 10 raised to the power times 10 raised to the power 4, 1.75 times 10 raised to the power 5, 1.25 times 10 raised to the power 5, and 3.75 times 10 raised to the power 3. So the correct option is 1.25 times 10 raised to the power 5 Newton meters. Now, let's look at atmospheric pressure. What is atmospheric pressure? Atmospheric pressure increases with depth, but decreases with height. At sea level, normal atmospheric pressure is 660 millimeter mercury or 76 centimeter mercury, or it can also be taken as 10 raised to the power 5 Newton per meter squared. So those are the values for atmospheric pressure: 660 millimeter mercury, 76 centimeter mercury, or 10 raised to the power 5 Newton per meter squared. Now, let's look at a question that will require atmospheric pressure here. Now, the atmospheric pressure due to water is given as 1.3 times 10 raised to the power 6 Newton per meter squared. What is the total pressure at the bottom of the ocean? Of 10 meters. Notice that we said that pressure increases with depth. So it's going to be the pressure of the water. It's going to be the atmospheric pressure, which is given, then plus the pressure at the bottom of the ocean at that point. And the pressure at the bottom of the ocean will be given by the density of water multiplied by the height, which is 10, multiplied by gravity. So we now add that to the value of the atmospheric pressure that was given. So if you do that, you are going to have the values that are are gotten above. So here you are going to have this is 1300000 added to 10000. That is 10 raised to the power 5. 10 raised to the power 5 plus 1.3 times 10 raised to the power 6. So if you add them together, you're going to have 1.4 times 10 raised to the power 6. And so you go back to your options. And so here we have 1.3 times 10 raised to the power 7 Newton per meter. Here are 1.4 times 10 raised to the power 6 Newton per meter square. Here are 1.4 times 10 raised to the power 5 Newton per meter square. 1.1 times 10 raised to the power 5 Newton per meter square. So from here, you can see that the correct option is option B, which is 1.4 times 10 raised to the power 6 Newton per meter square. Now, let's look at Pascal's principle. What does Pascal principle state? Pascal principle states that the pressure exerted in a fluid in a container or a vessel is uniformly distributed throughout the fluid on the walls of the container. I used to say that if a fluid is poured into a container, the pressure that is felt on the walls of the vessel are uniformly distributed because the force that is applied into the fluid is uniformly distributed throughout the fluid. So at any point in the vessel, the pressure that is felt is uniform. So if you look at the diagram that is shown here, we will notice that this principle has been used to design the hydraulic press system. The hydraulic press system is a system that uses little effort to generate big outputs. So with a little pressure, you can lift a load that is far, far bigger than the effort that is applied. So normally, the hydraulic system is designed with horizontal U-tubes where the diameters are not equal. The input usually carries a narrower diameter with a smaller piston, while the output, which carries the load, carries a bigger diameter, which carries the load. So with a little effort at the input is going to produce a good output. So it is what is used in jacks to lift up loads. Okay, so from the hydraulic press, we see that the input has an effort, F1, with an area A1, and the output, which usually carries the load, F2, and A2. Now, the input F1 and A1 are usually smaller than the output, which is F2 and A1. So now, let us bring out our formula. We already know that pressure is equal to force over area. Pressure is equals to force over area. So as shown here, pressure is equals to force over area. And we notice that the pressure that is in a hydraulic system is uniform. So the pressure that is in F1, the pressure that is in the first cylinder will be the same pressure in the second cylinder. So if you have P is equals to F1 over A1 is equals to F2 over A2. So now, if we decide to cross multiply, we are going to have F1 A2 is equals to F2 A1. Why F2 is the force expanded on the bigger cylinder or the large piston. While A2 is the area of the large piston, F1 is the force exerted on the smaller piston, while A1 is the area of the smaller piston. Now, the velocity ratio of a hydraulic press is given as distance moved by the input, which will give you H1 multiplied by A1, which is equals to H2 multiplied by A1. H1 and H2 are distance moved by the small piston and distances moved by the large piston, which gives you the velocity ratio of the hydraulic press system. Now, let's take a question. It says the area of the effort and the load pistons of a hydraulic press are 0.5 meters square and 5 meters square respectively. If the force F1 is 100 newtons, if the force F1 of 100 newtons is applied on the effort piston, what is F2 on the load piston? So previously, we have already stated that pressure is equal to force over area. And we know that F1A2 is equal to F2A1. So if we bring out the parameters from this question, we notice that F1 is 100 newtons, while A1 is 0.5 meters per second, while A2 is 5 meters per second. 5 meters square. 5 meters square. Good. So substituting into the formula F1 A2 is equals to F2 A1, we are going to have 100 multiplied by 5, which is our A1, will be equal to F2, which is what we're looking for, multiplied by our A1, which is 0.5 meters squared. So if you substitute that appropriately, you are going to have F2 is equals to 100 multiplied by 5 will give you 500, divided by A2, which is 0.5, divided by A1, which is 0.5, and 500 divided by 0.5 will give you 1000 newtons. So now let's go to the options to see which of the options is actually correct. A says 10 newton, B says 100 newtons, C says 500 newtons, and D says 1000 newtons. So from here, we can see that the correct option here is 1000 newtons. Now, let's look at Hare's apparatus. A Hare's apparatus is a device that is used for comparing the densities of liquid. The device is designed to compare the densities of liquid. So normally what you have is that water has a known density. So you are going to compare it with possibly mercury, kerosene, or any other liquid that you don't know the density. And the rule says that the pressure in one component is equal to the pressure in the other component. As you can see from the diagram here, there is a tube that is knotted at the middle. So once you unknot this point, the pressure in the tubes begin to rise onto the appropriate level, since the densities of the liquids are different. And once each of them attain equilibrium, one is usually water and the other one is unknown density. So that allows you to measure the density of the one that is not known. And since the cylinder is calibrated, you can take the individual height. So from Hare's apparatus, it says that rho H1G is equals to rho H2G, which means that the pressure in The first cylinder is usually equal to the pressure in the second cylinder, which is the tubes. The pressure in the first tube is equal to the pressure in the second tube. Since gravity is constant, so they will both cancel out. So you are going to have the formula ρ1h1 is equals to ρ2h2. So now, let us see how we can apply this formula in the next question. Now we have a U-tube there that shows the column of liquid X flows in water in a U-tube of uniform cross-sectional area. If the density of water is 1,000 kilograms per meter cube, find the density of X, which is the liquid we do know. So from the formula that we just saw, we saw that the pressure in the first tube is always equal to the pressure in the second tube, since it's a U-tube. First pressure in the first tube, the pressure in the first tube and the pressure in the second tube, they are always equal. So we just equate their values of pressure, and then we now look for the unknown density. And pressure here is rho hg. So from the question, we are going to bring out a few parameters here. We saw that the first distance here, h1, was given. So if you look at the U-tube, the first cylinder has a height of 10 cm and the second cylinder has a height of 20 cm. Since we are all required to solve them in meters, so first of all, we are going to convert them to meters. So that will be 10 divided by 100. So we're going to have 0.1 meters. And then on the right side of the column, which is the second tube, we are going to have 20 divided by 100. So now if you plug that into the formula, ρ1 h1 multiplied by g is going to be ρ2 multiplied by g multiply ρ2 multiplied by h2 multiplied by g. G will cancel out. So since we are looking for ρ2, which is density 2, so with the appropriate substitution, we are going to have 0.1 multiplied by the density of water divided by the height in the second column, which is 0.2. So that will give you 500 kilogram per meter cube. Thank you. Thank you very much for staying tuned to our series of episodes on these topics in physics. We hope you have really enjoyed it and brightened your knowledge. For more on question and answers or topical issues in physics, we ask you to log on to our YouTube channel, prepstation.ng. Thank you very much.